Hello, in today's video we're going to be discussing empirical formulas. Now, as a chemist, we actually have two different types of formulas that we're going to come in contact with a lot of times down in the laboratory or just across literature. We have something called the molecular formula and we have the empirical formula. Now, the empirical formula is the smallest whole number ratio of all the elements within a certain molecule. The molecular formula is the actual amount of each element found within a formula. So what is that? How does that work? So let's take an example. Let's take dicarbon tetrahydride. So C2H4. We know that this is definitely not the smallest whole number ratio, but this is the molecule itself. Dicarbon tetrahydride. That exists out in the world. And this thing has a molar mass, molar mass of 28.06 grams per mole. Okay. Now, comparing the molecular formula to the empirical formula, to go from molecular formula to empirical formula, all you have to do is find the smallest whole number ratio. So if we divided both of these numbers by 2, we would get CH2. These have the same ratio of, for every one carbon, there are 2 hydrogens up here. The same thing is happening down here. So this is the empirical formula. Now for the empirical formula, the molar mass is 14.03 grams per mole. Why do we care about this information? Well, instrumentation down in a laboratory will be able to give us the empirical formula. However, in most cases, we are not going to be able to identify the molecular formula through the instrumentation alone. So we'll have to put a sample. Let's say we have this dicarbon tetrahydride, had a sample, we'd have to run it through 2 instrumentations. One to calculate the molecular formula's molar mass, and one to calculate the empirical formula, the ratio of carbons to hydrogens. So how do we go from one to another? Let's say we don't know C2H4 is our molecular formula, but we do know the molar masses of the molecular formula and the molar mass of the empirical formula. We know that we can take the ratio of those 2 molar masses and identify how much smaller our empirical formula is than the molecular formula. So let's see what this works. Let's say we take the molar mass of the molecular and divide it by the molar mass of the empirical. This would be 28.06 grams per mole divided by 14.03 grams per mole. When you plug this into a calculator, you end up with the number 2. What this tells us, by taking the ratio of the molar mass of the molecular formula divided by the molar mass of the empirical formula, this number will tell us exactly how many times smaller our empirical formula is than our actual molecular formula. And the only reason why we're talking about this is because instrumentation down in the laboratory can tell us the empirical formula. A lot of times it cannot tell us the molecular. So we're trying to figure out a way to get to the molecular formula. So since we know this ratio is 2, our empirical formula is 2 times smaller, what we can do is we can take that number, 2, and multiply it by the empirical formula. Distributing this 2 to everything, all of the subscripts, we end up with C2H4. Okay. So, if we did not know the molecular formula, we did not know C2H4, but we did know its molar mass was 28.06. We did know the empirical formula is CH2, and we did know the empirical formula's molar mass, we could still calculate what the molecular formula is. And I know this seems kind of weird and strange the way that I explained it. However, we will be doing a lot of different problems of like this type in class. So the whole point of this is we will not know the molecular formula. We won't know that one. However, we will be given information about its molar mass, the empirical formula, and the empirical formula's molar mass. From these 3 other parts, the empirical formula, the molar mass of the empirical formula, and the molar mass of the molecular formula, from the pieces in red, we can calculate what that piece in green is. Okay? And the way we do that is we take the molar mass of the molecular, divide by the molar mass of the empirical, find out what the ratio is. This will always be a whole number, because the empirical is always a smallest whole number ratio, so it'll always be a whole number, and then just multiplying the empirical formula by that whole number. And that is how we get our molecular formula. Now we do this a lot of times in laboratory, like I said before, and so I just want you to be aware of how to do this. We'll cover this a little bit more in class tomorrow. So with that, I want to say have a great night. I'll see you all in class tomorrow.